In this video, we will solve a problem on utility maximization. This question was asked by a brother on Telegram channel of Econ Maths. The question is, if U is equal to Q1 times Q2 square minus 10 Q1 is a consumer's utility function, that means utility is a function of two commodities Q1 and Q2, and the income of the consumer is $120, we have to find out the optimal purchases of the two commodities. If per unit commodity prices are, that means price of good one is $2 and price of good two is being given as $8. Okay, so how do we proceed? Let's see. So our endeavor is, and let us see what we are being given. We are being given a utility function that is equal to q1 q2 square minus 10 q1. This is our utility function. Price of good one is being given as $2. Price of good two is being given as $8, and income, let's denote it by M, is being given as $120. Okay, we need to find out the optimal purchases by the consumer. Graphically, what exactly we are bound to find out. So if I draw the graph, let us say we have Q1 on the horizontal axis and Q2 on the vertical axis. Given the budget line of the consumer, our endeavor is to reach to the highest possible indifference curve. That means with the given budget set, consumer wants to achieve highest possible utility. That means our optimal bundle will lie at a point where the indifference curve is tangent to this budget line. Okay, so this will be our optimal bundle. So when the budget line and indifference curves are tangent to each other, now the condition for this tangency is that our marginal rate of substitution between two goods should be equal to the ratio of the prices. That means P1 upon P2. That means MRS denotes the slope of this indifference curve, and P1 upon P2 denotes the slope of budget line. When slope of indifference curve is tangent to the slope of the budget line, we say consumer is purchasing optimal bundle. And algebraically, what we are supposed to find out, simple thing, our endeavor is to maximize. Okay, we want to maximize our utility. We want to maximize U is equal to Q1 Q2 square minus 10 Q1 subject to the budget constraint. And what is the budget constraint? Simply P1, price of good one, times units of good one, plus price of good two times units of good two, that is Q2, should be exhausted. That means that should the expenditure should be spent out. Okay, that means what is price of good one? That is 2, so I can write in place of P1. We want to maximize this utility subject to this budget constraint. In place of P, we have 2. So 2 Q1 plus P2 is 8. 8 Q2 should be equal to 120. That means income should get exhausted on the purchase of the goods Q1 and Q2. Okay. Now, what is the tangency condition, or optimization condition? That is our MRS should be equal to the price ratio P1 upon P2. Okay, MRS is simply the slope of indifference curve. Okay, slope of IC should be equal to the slope of budget line. Let's denote it by BL. Okay, by MRS, what we mean? MRS is simply the marginal utility of good one upon marginal utility of good two. It should be equal to the ratio of the prices P1 upon P2. Okay, MU1 means the partial derivative of utility function with respect to good Q1. That means marginal utility of good X1 means the partial derivative of this utility function with respect to good Q1, divided by marginal utility of good 2 means the partial derivative of utility function with respect to good 2, and it should be equal to the ratio of the prices, that is P1 upon P2. Simple thing, काम बकवास नहीं किया. So what is the partial derivative of this function with respect to q1? Derivative of q1 will be 1, so we are left with q2 square. Q2 square, derivative of q1 here is 1, so we are left with minus 10. So this is du upon dq1. To this we divide du upon dq2. This time we take derivative with respect to q2. Okay, derivative of q2, so we have q2 square, its derivative will be 2q2 by power function rule, and we have q1 also with this, so we will get twice q1 q2, and derivative of this second term will be obviously equal to 0 because we are taking the partial derivative with respect to q2. Okay, and it should be equal to the ratio of the price of good 1 is 2, price of good 2 is being given us as 8. Okay, I hope I am making myself clear. So months, let us write here other stuff. Let us solve this a little bit. So this, let's write it here. 2 1s are 2 2s are 4. Let's write it here 1 upon 4. Okay, I'm just simplifying it here. Now what will we do? Let's do some cross multiplication. So we have 4q2 square, 4q2 square minus 40 is equal to twice q1 q2. Okay, simply I'm cross multiplying this stuff. So dividing both sides by 2, we will be left with twice q2 square minus 20. Okay, 40 divided by 2 is 20, should be equal to q1 q2. Okay, let's further solve this out. So we can write it in this fashion. If I transpose it here, so twice q, or let us solve it here for q1. That means q1 will be equal to twice q2 square divided by, I'm just dividing both sides by q2 minus 20 divided by q2. That means our q1 is equal to 1 q2 will get cancelled, so we will get twice q2 minus 20 upon q2. Okay, now what will we do? We simply plug the value of q1 into our budget constraint. So in place of q1 here we plug the value. Okay, simply plug q1 is equal to this stuff into the budget constraint. That means we have to, in place of q1 we have this stuff, that is twice q2 minus 20 divided by q2. Then we have plus 8 q2 plus 8 q2 is equal to 120. So this becomes 2 2s are 4, q2 minus 4, 220 is 40 upon q2 plus 8 q2 is equal to 120. Okay, so we can do one thing here again. So these are the same terms, we can add them up. So 8 will give 12 q2 minus 40 divided by q2 is equal to 120. Okay, so dividing both sides by 4, so we will get if we divide both sides by 4, so dividing here 4, here 4, and here 4, so what we will get? So 4 1s are 4 3s are, so we will get 3 q2 minus 10. Actually, okay, it's 4 1s are 4 10s are 4 q 40 na laguniyat 10 divided by q2 is equal to 30. 4 1s are 4 3s are 12. Okay, so multiplying, so this becomes 3q square, 3q, multiplying this with this stuff, so 3q2 square minus 10 divided by Q2 is equal to 30. So this becomes 3Q2 square minus 10 is equal to 30 Q2, or we can write it in this fashion: 3Q2 square, transposing it here, minus 30 Q2 minus 10 is equal to 0. Okay, so this is actually a quadratic equation. We can use the quadratic formula to find the value of Q2. Okay, so let me derive it here, then I will rub this. So we know it is our A, the coefficient of Q square, sorry, is A, coefficient of Q, let's denote it by B, coefficient of constant term is C. So Q2 will be equal to minus B plus minus, simple thing, B square minus 4AC divided by twice A. Okay, let's see what is B. First we have minus from the formula. The value of B is minus 30, so we have minus 30. Then we have plus minus, then we have, you know, uh, B square, that means minus 30 square, minus 30 square minus 4. From the formula, the value of A is 3, the value of C is minus 10. Okay, so let me write it here, minus 10. So we have minus 10 divided by twice A. 2 times the value of A is 3. Okay, so what it comes out to be, so minus into minus is plus, so it gets 30, and look, yes, a B. So we have 30 plus minus, so 30 square, square of a negative number is positive, so this is 900. So we have minus into minus is again plus, so 4 3s are 12, 10s are 120, plus 120 divided by 2 3s are 6. Okay, that means we get this 30 plus minus, this comes out to be what we call it, one now that 10,020 divided by 6. Okay, so solving it further, so this is the value of Q2. Let me see if I have the space left here. So this is 30 plus minus, so Q2 will be equal to 30 plus minus under root 1020 comes out to be 31.94. I have calculated it, divided by 6. Here you can see Q2 will be equal to, either Q2 is equal to 30 plus 31.94 divided by 6. Okay, or Q2 is equal to 30 minus 31.94 divided by 6. Okay, so we got two values for Q2. Which one we want to take? We know the consumer can only consume positive amount of a quantity. Here you can see 30 minus 31, it will come out to be a negative number. The value of Q2 will come out to be negative, so we can rule out the value of Q2 is equal to this 30 minus, it comes out to be negative number. Here when we add up 30 with 31.94 upon 6, it comes out to be 10.32. okay, 10.32. okay, so let me rub this out. I don't have the luxury of infinite space and obviously time. So we got the value of Q2 when we solve with this. We got two values, one is negative, one is positive. We rule out the negative one because we can't consume the negative quantity of good. So Q2 is equal to 10.32. This is the optimal consumption of good Q2. That means Q2 will be equal to 10.32. To find the value of Q1, simply plug Q2 is equal to this stuff into here. Okay, in this function. So our Q1 will be equal to 2 times 10.32 minus 20 divided by again 10.32. Solving this out, it will become q1 will be equal to, this is 20.64 minus 1.94, it comes out to be 18.7. That means q1 will be equal to 18.7. Okay, so this is here 18.7. That means consumer will consume 18.7 units of good 1 and 10.32 units of good 2 to optimize his utility. Okay, and the total utility he will get will be equal to, so our utility will be equal to, just plug the value of optimal combinations into the utility function. So in place of q1 we have 18.7, in place of q2 we have 10.32, okay, square minus q1, that's 10 q1, in place of q1 we have 18.7, and it will come out to be 1804.6. This will be the utility that the consumer will get when he consumes the optimal combinations of good q1 and q2. Okay, I hope I make myself what I call it always clear. Thank you.